Oh, I just watched Pileofstuffs video on a fully discrete 555, so I thought I'd do the same sort of thing, but using an AT Tiny 85. Way, what a way to go! Well, here's the simplified circuit. As of course, I need an output, I need a threshold, a trig, and a discharge connection. I'll ignore the comp and the reset. We'll have a bit of fun. I'm going to look here. This is the typical pinout of a 755. This is a typical pinout of an AT Tiny 85, the 8-pin version. As we can see, the only real pin that lines up is pin 8 VCC, as we need an output for the discharge, we need an output for the output signal, and we need some threshold and some trig. And over here we're a bit limited because obviously we need to use the ADC, we need to use two outputs. It's not going to be pin for pin compatible. And then we look here, this is the NE555, and this is basically the stable circuit which we're going to recreate, pull up on the Q output, and then we have like the charge and the discharge resistors and the capacitor to ground. And on the AT Tiny 85 we've basically got the same connections. And on here, TR, threshold and the trigger are joined together. So on here, one input doing the same thing. Because if we go back up to the circuit here, one of them triggers at a third of the supply voltage, and the second one triggers at 2/3 of the supply voltage. Whereas we're not going to bother with that because we're going to use an ADC, and we will just change the trigger point of the ADC as to whether we're looking for the low level or the high level. And again, that's what it would look like out the data sheet, and there are the signals that we'll be expecting to see on the scope. So hopefully it will do it. As I say, the discharge function will be provided by switching the port pin between an output, which will be set low, and an input. Now we need to do this because obviously when the discharge isn't discharging, the current wants to come down through RA, through RB to charge up the capacitor. So we don't want this to be an output because obviously we would then charge the capacitor through RB. So what we will do is when we want to discharge, we'll make the output an output set low, so the capacitor will discharge through RB and through the input. And then during the charge part of the cycle, we will make this an input with no pull-ups, so it will basically become a high impedance, and the charge current will all come through via RA. So it will give us quite close to the what we want, and we will do the same with the output. We will convert it to an output to pull low, and an input to let RL pull it high, again to give the appearance of an open collector output. So here we can see the on and off, the high and low from the output. This is the threshold or the voltage across the capacitor. As you can see, during the high state we are exponentially charging it up, and during the low state it is exponentially dying away and then repeating. Unfortunately, the minimum point is 1.9 volts and the high point is 3.48 volts. Not quite what I wanted, but close enough for what I was just playing around really. You know, if I adjust one of the pots, you can see it affects the cycle times. It's all hit and miss, it's all just stuck down for playing. Well, here's the program. I'm not going to go into much detail about it. There's the usual set of includes, include the AVR interrupt part and a bit for a delay, usual things, standard IO for IO pins, standard lib for using uint 16-_T, things like that. And you can see we got a couple of defines. We got the max ADC value, which is the point at which the discharge output should be set low, and the point at where we're at the low part of the cycle and the discharge output should be set to an input to allow the capacitor to charge back up. A couple of variables. Simple interrupt, reads the 2 bytes that make up the 10-bit ADC reading, merges them together, and then basically just says if it's above the maximum value, set the output low and set the discharge value to an output. And then again down here, if the value is the low point, set the discharge pin as an input, and again set the output as an input. Very simple. And then if it's in between them, we don't do anything, and at the end, before we return, set the ADC running again. So very simple. Every time the ADC times out, the interrupt gets called, we check, is it high or is it low, set accordingly. There's a little bit in the setup, clear the interrupts, set the muxes, set the bits on the ADC, and then we go into the main one where we've called the setup, we set the output, we enable interrupts, and then we go into a while loop and do nothing. So that's about it. Not much to it, as it was just a bit of fun. So if you like what you see, hit the subscribe button or the notification bell, and I'll catch you on the next one.